There's two separate systems for pilots to understand this system well. There's a hydraulic system valve here that is the muscle work to raise and lower the gear. And it's controlled by this lever. And then there's the spade latch, which we use the word spade and latch kind of interchangeably. But this mechanical system on the floor of the cockpit raises and lowers, let me make this silent, raises and lowers the spade. Let me get this out of the way.
Okay, I get close up. Okay, there you go.
Yeah, can you do something here?
Good.
This little thing looks like a British shovel or something, just by the shape of it. And the handle on the floor raises this out of the way so the gear can retract. Or, let me show you. Or, with the handle in the 45-degree position, not clipped to the floor and not raised fully. The spade is down as far as it ever goes, but it can be sprung up by pressure. These are really parts out of the real airplane. These parts here all exist in the real airplane. This is the real actuator rod end that comes in under this spade, and it forces the spade up momentarily but gets underneath it. Okay, so that's what is the mechanical down lock for the landing gear. So I just want you to know to start with that the mechanical system of the spade, controlled by the lever on the floor, is entirely separate from the hydraulic system. And this rod is the interconnect safety. Okay? So with that overview, we'll go through the normal retraction and extension cycle. Okay? Just so we understand the difference between positive lock, spring lock, and latch raise, that's the three choices on this floor handle. In the spring lock position, which is a 45-degree angle, anything coming by, when the landing gear comes down, it can spring this up and down, see? If this is clipped to the floor, like that, this is now driven metal to metal inside here, and you cannot push up on this. You hear it clicking maybe. That's the positive lock position, which is appropriate when the gear is down and captured. When the gear is down and captured, you want to be in positive lock prior to landing. And it stays there all the time you're on the ground. Okay? The latch raised position is further up. There it is. More nearly 90 degrees. And you see the latch is out of the way. And that would be necessary if we wanted to retract the gear. You have to raise the latch before you can retract the gear. So pulling the handle all the way up till it holds itself is a normal thing to do prior to opening the valve in the up direction to raise the gear. Okay? So that's the three positions on this mechanical spade latch handle. There, I think that ends that side. Okay, so this is a Basler part that is a service bulletin that's a voluntary compliance, I imagine. And what it does, the advantage to this system is it gives you a fine-tune adjustment for the length of this rod from the wheel that turns to the spade, okay? So that's an alternate part, if that explains it. I'm sure it can. So we're cruising, and I want to clarify one little thing that I forgot on the normal gear extension. When the flying pilot calls for gear down, flaps 1 before landing check is the phrase I like. When he calls for gear down, The non-flying pilot should look at this and confirm that the latch handle is liberated from the floor. It's not clipped like this, that would be bad, and it's not all the way up, that would be bad. It needs to be in the spring lock position prior to lowering the gear. And we'll go through what can happen if we forget to do that. But it's a very important thing that when the flying pilot says gear down, the non-flying pilot looks to see that the floor latch handle is free, it's liberated, before selecting gear down. Okay? And that's all. So my next item is abnormal operations, and the easy one that we've had several times here in my career is we've come to the airplane parked on the ground, and we find this latch control handle has been fully raised by no one that will admit it. Persons unknown. The most likely case of that was the ground crew tried to move the airplane, and they knew they had to release the tail wheel lock. And they thought, wow, the tail wheel's below the floor, we'll grab one of these levers that's on the floor. And they do this, and then it won't move forward, and there it is. Now, you might notice when you walk on the airplane that the latch handle is fully raised. If you go to the wheel well first, you might see that the actual spade latch thing is retracted. It's up. Very dangerous thing. Leave the pin in. Don't take the pin out. Okay? In that case. Now the easy fix for that, I'll show you. What holds this up is this rod. And it's a very simple thing. If you pull a little more up on this and move this lever forward, you're back in normal business. So I'll show you that a couple of times. When this gets inappropriately raised all the way up, what's holding it up is the interaction of these parts. So if you unload it by pulling, move this part forward just a little, you're back in business. Now the spade is dropped down and positively locked. We dare continue with our pre-flight inspection. We're going to simulate that we're flying, so I'm going to get the gear up to start with. Okay, and I'll use this rod to where the gear is up. Okay, so now we're cruising, we're flying. This is all normal things. It's normal to see the gear on safe flight on the entire cruise flight. This should be in the intermediate position, which is called spring lock, the entire cruise flight. And let me give you a scenario. We're going to call this whole thing pinching the spades, which is a bad thing. Again, I'll remind you this little latch is called the spade. And we'll go through the scenario. Let's say you've flown a long time and the pilots have moved the seats, moved seating positions. They've stepped out of the cockpit and stepped back in. Somebody came along and stepped on that. So the lever is indeed in what we call positive lock. So that prevents this from moving. Okay? Now,
Want to show it again?
Go ahead.
Want to show it again?
Sure. It prevents, this is positively driven metal to metal, so it cannot spring up. Okay? So we're kind of set up for a problem already. The flying pilot says, landing gear down. The non-flying pilot doesn't do his job and check that this is liberated. He doesn't look first, he just selects down. So, the gear comes down and it does not go past the latch. It can't go, you see? It's just pinched hard. So the hydraulic system presses the full pressure here. Both needles come up like normal. You have landing gear pressure gauge up and the system pressure gauge up. and you select handle neutral, oh, there's no green light. Ah. You think, oh, look, this has been clipped down all the time. Well, let me unclip it. If you try to pull this up, the cables will be in a great deal of tension, and this is pinched so hard you won't be able to raise this up without risking damaging things. So this won't work, you can't pull it up. Putting it down or the spring lock makes no difference. Well, you think, I'll raise the gear. Oh, this safety won't let you raise the gear. So, the condition now, to continue, the flight crew should just abandon the landing to start with, go out away from the airport. One of the pilots has to get out of their seat and disconnect this interconnect rod, okay? So this rod that goes down through the floor has to come apart at the upper end. Every Basler airplane, every BT-67 that leaves the factory has what we call a little diaper pin that requires no tools. It's just a little safety pin that holds a castle nut. Instead of a cotter pin, we have this safety pin. And this is always just finger loose when it comes out of the factory, so there's no tools required. So, the castle nut comes off, there may be a washer or several, the bolt comes out, and just knock the interconnect rod off to the side. Now we have a completely separate hydraulic system from the spades. Now we can raise the gear. Sure enough, the gear comes up off the spades. Things are good. And now we can select gear down again because they're completely separate. We're in spring latch, things are good, the gear comes down, and it's captured. Captured properly. Both pressure gauges come up. Neutral, we have a green light, positive lock, and we can land the airplane just like this with all the confidence we normally have. To reassemble this, we can do that on the ground. Okay? So that's the pinch the spade scenario. And it's caused again by the non-flying pilot not checking prior to lowering the gear that this latch is in spring lock position. That ends that side. So we've landed the airplane with it, after a pinch spade incident, we've landed the airplane with the interconnect rod disconnected. And we're just have all the confidence that we normally would have. Taxi up, shut down. We'll put the safety pins in, so nothing can go wrong. And then we'll reassemble this. To make room for this little dog to go, you have to move this part forward with your finger. Ah, now it's in there. And then the interconnect rod goes in. It's important to get the bolt in from the rear. The head of the bolt is away from you so that we can get the castle nut on easily. Replace the washers as you found them. And spin this on again just finger tight, checking for hole alignment, and use the little safety pin and put it together, and we're back in normal business. What makes the green light green, the gear down light, is both landing gear fully in the wells. There's a switch with a little teeter-totter affair, and there's a switch in each wheel well, and this switch on the valve handle itself, the hydraulic valve handle, has to be in neutral and outboard to engage that switch right here. Okay? And if it's not down, it's unsafe. And that unsafe one is labeled gear up. The gear could be down, but unsafe. That's what that really ought to be labeled. Okay? Okay, so what makes the green light green is the condition. What it's supposed to mean is both gear are fully down and the gear handle is in neutral. That's what it should mean. And there's a switch in each well, and the switch at the valve handle, the hydraulic valve handle, neutral and outboard. So the question comes up, what if there's not a green light in flight? So let's put the airplane in flight, check out, retract the gear, and we'll simulate the hydraulics by using this little rod there. Okay, so my power climb procedure, this is how it should run. Gear unsafe, it's actually labeled gear up, and we cruise that way. So the command is made for gear down, and for whatever reason, we don't get a green light. Let's see. If we come to here and we don't get a green light, and I can't even simulate it because the simulator is working appropriately, but if we don't get a green light, maybe one of these switches has lost its connection, or the wire is broken, or this little teeter-totter has come out of adjustment or something. It could be the bulb has failed. Okay, so the first thing I would do is swap bulbs if I could. Let's see. If the swapping the bulbs doesn't help, you can see the landing gear on the, if you go back in the main cabin, send somebody back to the main cabin, look at the front side windows, you can actually observe the gear. Some of our operators have marked the knee joint to confirm that it's down, okay? It's nice to know you can observe the landing gear from the front window of the main cabin. If the hydraulic system is working normally, by that I mean we have fluid and there is pressure, we can confirm that the sequence is correct. We can raise the gear again and put it back down just to confirm with both pilots watching that we did it right. Okay, so we'll do that. Let's gear up. And then gear down. And everybody can watch to see that it's a similar amount of swing time. The pressures rise. Gear handle to neutral. We should have a green light, but in our thing we don't. Okay, we still don't have a green light. We'll go ahead and try this anyway. One thing a person could do to try to decide if the gear is really down and safe would be, again, to disconnect this interconnect rod and try to raise the gear. That would work. If the gear stays down, the latches are latched. So, and again, we would do that with the diaper pin coming apart. You've seen this before, but I'll demonstrate it again, just how easy it is. There, now the interconnect is gone. If we raise the gear, there's nothing preventing that. Full hydraulic pressure is going to try to pull this up, and sure enough, if they do not retract, and you can confirm it by no motion in the hydraulic cabinet, you can confirm it by looking out the front windows of the main cabin. If the gear are down, you're good. I would select gear down again to pressurize the downline so the hydraulic system is pushing this way on it. Back to neutral, you'll have two good pressure gauges and land with the confidence you normally have without a green light. To go on with that scenario, if for whatever reason one of the gear does come up, the latch is out of control, maybe the cable has failed and this is full of dirt or something so that the latch is raised on one side and not the other, it's possible that would occur. I'd like everybody to know it's really important to pressurize the downline so you have two pressures that are good and return this to neutral. Very important to land with this in neutral because you'll trap the pressure in the actuating system, and for the gear to collapse would take a burst hose or a burst line, tremendous pressure that the system normally won't ever make. So it's important to have the handle in neutral to land. If you had the handle down, all four of these ports are open here. And if the gear tries to, as the gear tends to collapse, the fluid will go the wrong way, backwards through that valve. And there's a 1,000 pound system pressure relief valve that would allow the fluid to go back into the reservoir. So landing with the gear handle down would be more likely to collapse than landing with the gear handle neutral, where the system, where this valve traps the fluid. Okay? So I want everybody to know that. And to continue with that scenario, if you were to land with a suspected unlatched latch where the gear was attempting to collapse, you'd want to not exceed, with this trap, with this in neutral, the landing gear downline gauge, the lower of the two gauges, would tend to rise as the gear tends to collapse. That gauge would go well above 1,000, it might go to 1,500, it might go way up. We have documentation that says do not exceed 1,500 pounds on that bottom gauge. And what's likely to do that, what the brakes, if you use the brakes at all, they tend to collapse the gear. The torque of the rolling tire goes into the axle and turns it the same way as collapsing the gear. So the less brakes the better, no brakes is best. Use beta, reverse, stop straight ahead. You might even consider putting a car under each wing and delegating somebody else to put the pin in. That's the secret.
You are on.
Yeah, and we at Basler would like to thank Stan McGrew for building these training pieces that he's given to us. Stan is retired and he lives in Utah, and we certainly appreciate his dedication and skill. Thank you.
I just don't know who we're gonna get for your stunt double though
My
when you do,
stunt double?
when you do the stunts,
Yeah. Well, I need somebody with a pillow. We gotta have a good costumer too. Put that pillow here, and wide back. And all that.
When I was a kid, we had a neighbor and he had been stunt double for John Wayne on a couple of movies.
Really? Oh, man. Oh,